Hello everyone. So I'm posting this video for the chapter number 18th of unit geometry, and this is especially prepared for preparation of tangents and the chords. So I'm going to discuss the property of tangents, the property of intersecting chords, and how and sometime we also use property which belongs to circles as well as to the chords of the circle. So both give you a question, will be giving you a question which will be the combination of the property of circles as well as of that of tangents. So here I will try to first of all make you aware about the properties you're going to use in the question. So the questions, so the properties which belongs to tangents. First of all, in this chapter we're going to do two things here: the tangents and the intersecting chord. The first part belongs to the property of tangents, and then I will take up to you to the next topic, that is intersecting chords or property of intersecting chords. So let us understand what a tangent is actually. So first of all, we should be knowing that what is a tangent and how does tangent behaves, and what is the property which make a line a tangent to the circle. So I'm simply making a circle. Now you all know that circles have radius, circle have chords, circle have diameters, they have radius, they have chords to them, they also have tangent to them. So if I define the chord, the chord is the line which basically join 2 points on the circle. So if I make a circle here and I join two lines like this is a chord in a circle, making two segments. That's another part. So this chord makes two segments. I will take it again later on the chapter, but for a while I focus on the tangents. When I keep on reducing this chord so that point A and B comes close to each other, and there is a limiting value when this line only touch the circle at one point, so that A and B point coincide here. Now this line becomes the tangent to the circle. So tangent is that line which touch the circle only at one point. That is the eligibility for a line to become a tangent to the circle. The line which touch the circle at one given point is known as tangent to the circle. Now I take it up beyond, and that is the properties of tangent. So the first property I discuss with you, I draw again three circles separately: the line, and one more, the circle and the line. So this is the chord. Here there is no relation between circle and the line, but here this line is touching the circle at one point. This is a tangent to the circle, right? That is the one property you must always look for whenever you're trying to find out whether the line is tangent to the circle or not. It must connect the circle at one point. That makes it a tangent. So I move from here. Now I am taking some properties of the tangent. Now properties of tangent, like the first one. So the first property, not very important for the questions, but nevertheless we're going to do it as such. So the property is that that if I draw a circle and I have a tangent, then radius and tangent are always perpendicular to each other. Radius and tangent are always perpendicular to each other. So there is no other possibility to connect the radius and the tangent except that they are at right angle to each other. If there's a tangent and it connects the tangent at the point of contact, then radius has to be perpendicular to the chord. The first property, always remember it. Sometimes it becomes very important when we calculate the angles in a circle. We should use the property that radius is perpendicular to the chord. So angle would be 90 degree between the radius and the chord. I hope I'm clear about it. So the next property, now please take care of the second property, and it's going to be very important for you in the coming up questions. And what is that? So I take a circle again. The exterior point P, the circle center is say O. Now the one thing is that now you can guess how many tangents can I draw from this point to the circle. There is only two tangents which I can draw to the circle from one exterior point. There is no other possibility for a tangent, for a third tangent to be drawn from this point A, P on the circle. So I can draw maximum. So first thing you remember, note in your copy, that we can draw only two tangents on a circle, on a circle from one exterior point, PA and PB. Now we'll study about the properties of these two tangents. The situation is that these tangents are from same exterior point P and drawn on the circle. So you got this PA and PB. I simply join radius OA and OB. They got to be equal, and I draw the exterior circle, exterior point and the center. You see here that now I can prove these triangles congruent. AO equals to OB. There's a first point. Second point is angle OAP equals to angle OBP. They are 90 degree each. And the third point is that OP is common. So triangles OPA and triangle OBP are congruent by, say what, we got a right angle and a hypotenuse and one side. Congruency is by RHS. Now once they are congruent, all the corresponding parts are got to be equal. So you got these two angles equal, you got these two angles equal, and you got tangents also equal. So the best property we can have is that, so we have got three properties out of it. First one, PA equals to PB, APO equals to BPO, and third property, AOP equals to BOP. These angles, these three properties are coming up when we draw two tangents from a same exterior point. What is that? The first one, tangent drawn from exterior point on the same circle are equal. PA equals to PB. Very important property. Many questions use this property in the exam and in the exercise also coming up. Second one, angle APO is equals to angle BPO. Angle APO is equals to angle BPO means tangents are equally inclined. Please note down this if you want to. Tangents are equally inclined on the line which joins the exterior point and the center. So OP is a line joining center and the exterior point, and tangents are equally inclined to these lines OP, correct? PA and PB are equal and they are equally inclined to line joining center and the exterior point. The third property, both the tangents subtends equal angle at the center. So angle AOP and angle BOP. What these angles are? They're the angle subtended by the equal chords on the center and they are equal. Please remember these three properties are very, very important properties. So I take up the next property. The third property is, it's not very important property. Sometimes we use that property and otherwise we don't need that. So the property says that whenever I've got two circles connecting each other either externally or internally. So I got two circles center C1 and C2, whatever, and they are contacting each other at one point. I got the common tangent drawn to them. And when I join these two centers, so line joining the two centers of the circle in contact at one exterior point is always perpendicular to the common tangent. There's a common tangent here. So C1, C2 is perpendicular to the tangent. Please understand and remember this. Similarly, if circles are connecting or in contact with each other internally, so I got a bigger circle and I got a smaller circle. Here you can see the circles are again having the center C1 and say C2. So this line joining the centers of the circle in contact internally at point P is perpendicular to the common tangent at the point of contact. Please understand this point. They say that if two circles touch each other, the point of contact lies on the straight line through the center. So I add one more point into it. It is mandatory for the centers, the line joining centers, that it should pass through the point of contact. It is not possible for the line joining two centers that it may pass through any other point except the point at which circles are in contact. So the line joining centers mandatorily has to pass through the point of contact. Similarly here, now see, if I make a different diagram, so this is a bigger circle, it is not possible for this line to pass through here or here, which are not the point of contact. So the line on which both the centers reside or lies has to pass through the point of contact. I hope you all understand this point, right? So I'm taking up the properties one by one so that you may be able to understand what's going on in the questions later on. So now I will take up the questions of this. So I guess all the questions are clear to you. We can have question answer session later on, but right now I'm trying to solve the questions for you. So the first, we are solving the exercise number A of the 18th chapter. I will solve the question one by one. The radius of circle is 8 centimeter. Calculate the length of tangent drawn to this circle from a pointed distance of 10 cm from the center. You must draw the diagram for all the questions. A radius of circle is 8. A length of tangent drawn to this from a point P at distance of 10 cm from the center O. The tangent till point T and join OT. The radius is 8. This angle is 90. So OP is the hypotenuse. Simply apply Pythagoras theorem. OP square equals to OT square plus PT square. So OP square equals to say 10 square plus 8 is what is 10 here? I think I missed a point here. So let us slightly change things. I think the distance of 10 cm from center, this is 10. We got to find the value of PT. So we got OP square equals to PT square plus OT square. Correct? So 10 square equals to PT square plus 8 square. We got 100 minus 64, 36, and root gives you 6 centimeter. So length of tangent is 6 centimeter. I hope the question is clear. Keep on solving these questions in your copy one by one along with the question. It's a board question on 2012. The given figure, O is the center of circle, AB is tangent, AB is 15. AB is 15 and AC is this much only. This is 7.5. You see very carefully. This also radius. This also radius. Basically, complete OA is 7.5 plus R, and OB is R. This angle is 90 degree. So OA is the hypotenuse. So you got OA square equals to AB square plus OB square. That gives me 7.5 plus R whole square equals to 15 square plus R square. You open it up and solve it further, and that would gives you the value of R. From here you got R square plus twice of 7.5 into R plus 7.5 whole square equals to 225 plus R square. I can see that R square is cancelled. 15R equals to 225 minus, please find the square of 7.5 and put that here. I'm not solving it further. I don't want to waste time on calculation. That gives the value of R from here. That is what they are asking from us. So you should understand radius and tangent always meet at right angle, and this is the radius and this is the distance of center and the exterior point, and this is also the hypotenuse. I hope I'm clear to you all. Okay, interesting question. The property use tangent from same point are equal to each other. So you see here the first circle, the tangents are QA and QP. What do you think QA and QP are? They are equal. Property and second, QA equals QP equals to QB. Property, tangent from so from 1 and 2, QA equals to QB. The question is proved. Right? Easier one? Okay. Next question. The same question, slight twist. The circles touch internally. The bigger circle and the smaller circle. Show that the tangent drawn to the circle from any point on the common tangent. Excuse the diagram, please. The common tangent, and I draw two tangents here. P point, T point, A and B. So what is this? PT is tangent, PB is tangent, PA is tangent, PT is tangent. Take the bigger circle. On the bigger circle, PA equals to PT. First equation. On the smaller circle, from 1 and 2, PA equals to PP. Tangent from same exterior point are equal to each other. Fifth question. Two circles of radii 5 and 3 are in concentric. Bigger circle, smaller circle. Length of the chord of the outer circle which touch the inner. Language should be taken very carefully. So what is AB? Chord of outer circle but tangent to the inner circle. Smaller radius is 3, capital radius is 5. O, P, perpendicular. Radius and tangent are perpendicular. We got to find the value of the chord. So in triangle OAP, OA square equals to OP square plus AP square. As you can all see, the value of AP as 4. AP equals to twice of AB. That gives you 8 centimeter. Now, because P point is midpoint of AB, so P point is midpoint of AB, that means I got AP as 4 and PB also at 4, so AB is equals to twice of AP or 8 centimeter. I hope the questions are getting clear to you. Right, the important question. So I'm just putting the mark on this diagram only. Take it as P, Q, R, and S. Now you can see there are 4 pair of tangents. DP equals to DQ. CP equal to CS. BS equals to BR. AQ equals to AR. So when this is the first and second and third equation and fourth equation, they all are having the same property. Tangents from now I need to show that AB, we have got 2 parts, AR plus BR. So I add something like we should have AR and BR on both sides. So I'm adding the third equation plus I want CD. CD has got PC and BD. So PC and PD I got 1 plus 2. So I'm adding the equations, it will give me PD plus, so I want to put all the parts which have got CD on one side and AB on one side. So AB has got 2 parts and CD has got 2 parts. DP plus PC plus AR plus RB equals to other side. I want to have BC on one part, BS plus CS plus with the group here, and what else is required? AD, AQ plus QD. So this DP plus PC is CD plus AB equal to what is BS plus CS? BC. What is AQ plus QD? That is AD. The question is proved that the opposite sum of opposite side are equal of a quadrilateral circumscribing a circle. Okay, I hope the property is clear to you all. So this property, we sometimes got the questions of this property in the exam. So always remember, tangents drawn from exterior point are equal to each other. So I got the tangents dp and dq. Tangent is not dc, it is dp. It take the circle, tangent is finished there only. dp and dq, cp and cs, bs and br, aq and ar. And so I add the four equations in such a manner that I got the two parts of AB on one side and two parts of CD on the same side with a group, and add things that gives. So I make a group of DP and PC and AR and RB. All right, everybody. If the question is clear to you, same question, same properties. The only thing is that here now it is given to me that ABCD is a parallelogram. So make a diagram separately for you. Now, what is given? That ABCD is a parallelogram. To show ABCD is a rhombus. So to show a rhombus, that means I take up the proving part from the previous question that the opposite sides are equal, right? So it is proved that AB plus CD equal to BC plus AD. Now here this AB is equal to CD and BC is equals to AD. They are the opposite sides of a parallelogram. So what can I do is that I can replace this CD with AB here. I got 2AB, and I can replace this AD with BC here. I got equals to 2BC. So I got AB equals to BC, but BC equals to AD. So AB equals to BC equals to AD equals to AB. So parallelogram is a rhombus. That is the question. So there's slightly modification in the previous question. Because sides are equal, I replace the equal sides, and in a parallelogram where all side becomes equal, or to cut it short, whenever the one adjacent side becomes equal, the parallelogram becomes rhombus. And so this parallelogram which circumscribe a circle has to be a rhombus. Question number 9. Now again the same property we are dealing with. So all these questions are actually of the same property, right? So you see here, I put a cut here. Now this cut shows that tangent is AP and AR. BP equals to BQ. CQ equals to CR. So I need to show that AB plus BQ plus CR equals to BB plus CQ plus AR. I should add the equation. This is 1, 2, third. All are tangent from same point. So when I add them, AP plus BQ plus CR equals to AR plus BP plus CQ. So the first part is proved. is as simple as that. Nothing less and nothing more into it. The second part is slightly changed. That is that we want to show AP plus BQ plus CR is equals to half the. Now let us find out first of all perimeter of triangle. What is that? AB plus BC plus AC, the perimeter, and so equals to, right? And I can make the part of it. This AB has got two part AB plus BP, BC has two part BQ plus CQ, AC has two part AR plus RC. Now because AP and AR are equal, BP and BQ are equal, and CQ and C are equal. I want here AP plus, what is AR equals to? AP. What I need to have BQ. I keep this BQ, and what is the other part of BQ? BP. I replace this BQ with BQ plus the other part is I need to have CR. I keep CR, and CR is equals to CQ. I replace this CQ with CR twice of AP plus BQ plus CR equals to perimeter. So you got AP plus BQ plus CR equals to 1 upon 2 AP plus BQ plus CR equals to half the perimeter of triangle ABC. A very good question, slightly tricky, and you can always solve it taking the solution from here. Note it down once and again do it. It will give you a better idea of how the questions are being solved in this question. The next one, in the figure of question 9, same question again. I'm seeing the same diagram. So let us make a diagram for you in this. Better. I have to show that if AB equals to AC, then prove that BQ equals to QC. Now I have already proved that the perimeter is the sum is half the perimeter. Anyway, I've been given AB equals to AC here, so I simply put AB equals to AC. Now it has got AP plus BP equals to AR plus RC. You can see that we have AP, and we have split the parts of AB into two parts and split the part of AC into two parts. I need to show that BQ is equal to CQ. How can it be possible? So both sides AP can cancel by AR, because AP is going to be equals to AR. Property, tangents from same point. Are equal. That gives us BP equals to CR. What is BP equals to? BP is equals to BQ. And what is CR is equals to? CR equals to CQ. That gives me the value that BQ is equals to CQ. That what I needed to prove here. So I've solved these first 10 questions in the question. In this video, I'll make the videos in that sequence from 11th onward, 11 to, I think there are 22 questions in this exercise, 24 questions. In the next video, I'll solve the remaining 14 questions very soon. Keep waiting for the next video. I will be posting the videos of these chapters one by one. My effort is that before the board exam, I mean for the month of in the month of January or the last week of December, I start doing the live streaming for giving you a proper revision and practice for these questions. We will be solving the competency-based questions and the PYQs and the specimen papers and the previous year papers, and we will try to do a lot of many things. I'll send you some PDF for the practice of this chapter. For a while, I take off from here. Subscribe the channel, The Maths Box. Thank you very much.